Hi, welcome to Orozco's Lectures. I am Jose Orozco, and these are my lectures. This lecture is a pre-calculus lecture. I hope you enjoy it. This is chapter 3.3, which is on properties of logs. Right? And let's look at the properties. So we've got a property called the product rule. And what this says is that log base A of a product, so log base A of m times n, is equal to log base A of m plus log base A of n. We've got the quotient rule. All right, the quotient rule says that if I've got log base A of a quotient, so m over n, that's going to be log base A of m, and that was an m, there we go, minus log base A of n. And lastly, we have the power rule. And the power rule says that if I have log base A of m to the r, that's equal to r log base A of m. All right, so these properties of logs come in very, very handy, especially once we move on to talking about solving logarithmic equations. But for now, let's see why these rules will be true. And I'm going to prove the first one. I'm only going to prove the product rule. The rest are proved in a very similar way. So let's look at the proof of the product rule. And the proof of the product rule would be as follows. So let's say let x be equal to log base A of m and y be equal to log base A of n. All right. From here, we would know that, well, a to the x is equal to m and a to the y is equal to n. All right. So essentially here, what I've got is I've used the exponential, well, I wrote the logarithmic expression in exponential form in both of these. So what would that tell us? Well, then, if I have log base A of m times n, well, this would be log base A of a to the x times a to the y. And what would that mean? Well, this would give me, from rules of exponents, this would tell me that I have log base A of a to the x plus y. Right? So I have same base, different exponents, and I'm multiplying, add the exponents. But we know from the inverse property of logs that this is just equal to x plus y, right? Essentially, the log base A and the A cancel each other out. So now, well, x plus y, what was x? X was log base A of m. So I have log base A of m plus y, which was log base A of n. So there you go. We're done with our proofs. With our proof, we show that log base A of m is equal to log base A of m plus log base A of n. So a product becomes a sum. All right. And that's a good way to think about it, that a product becomes a sum because, well, why would that happen? We have a product of exponentials here. What happens there? Well, we add the exponents. That's why the product becomes a sum. Similarly, in here, a quotient will become a difference, all right, by similar rules. And applying actually the product rule a lot, you would end up with this power rule. All right, now let's evaluate. Let's see what this gives us. So evaluate. So let's say that I have ln of e to the 6 minus ln of e squared, right? So in here, there's two ways we can go about this. All right. First, I see that because of the quotient rule, I can rewrite this as ln of e to the fourth, ln of e to the sixth over e squared, which would then reduce to ln of e to the fourth, and then by the inverse property, that's equal to just 4, right? Because ln and the e cancel each other out. Alternatively, you could have said, well, ln of e to the sixth is just 6, ln of e to the second is just 2, so 6 minus 2 is just 4, right? Let's do another one. Let's say that I have log base 5 of the cube root of 5. Well, this would say, this is the same thing as saying log base 5 of 5 to the 1/3. Bring the 1/3 to the front. So I have 1/3 log base 5, but then log base 5 of 5 is just 1. So my answer there is just 1/3, right? Now, let's expand this idea. Let's say that I said, write the following. In terms of log of 3 and log of 5. What do we mean by that? So let's see. So in here, I'm going to say, let's say that I had log of 75. All right. Well, log of 75 would just simply be log of 25 times 3, right? Because 75 is 25 times 3. And in here, well, this is a product, so it's going to become a sum. So I'm going to have log of 25 plus log of 3. And then over here, this 25 is just saying 5 squared. So I have log of 5 squared plus log of 3. And finally, here with this power, I could put it to the front. So I end up with 2 log of 5 plus log of 3. And there you go. Our final answer is in terms of just log of 3 and log of 5. Log of 5, log of 3. So that's what we're saying here. Expand this as much as possible so that you end up with just logs 5 and log 3s. Let's do another one like this. Let's say that I have log of 9 over 125. Well, from the quotient rule, this would say that this is just log of 9 minus log of 125. And then we would say, well, log of 9 is the same thing as saying 3 squared. 125 is the same thing as saying 5 cubed. So in here, I'm just going to say, well, this becomes, from the power rule, 2 log of 3 minus, again from the power rule, 3 log of 5. And now our final answer is in terms of log of 3 and log of 5. All right. But let's kick it up a notch. So let's say I just said the following, expand. And let's say I have log base 4 of 5x cubed y. All right, let's just start with that. We're expanding log base 4 of 5x cubed y. Well, from the product property, I can say right away that this becomes log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. And the last thing I see that I can do here is I can use a power rule in the middle one. So I will rewrite this as log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. And that would be our final answer. All right. Now, at some point, I would like you to get comfortable enough with these kinds of equations or these kinds of statements to be able to go from the very first statement to the very last. What do I mean? I'm saying to go from here all the way to that line without having to do necessarily that middle step. Let's do another one. Let's say that I have log base 3 of 4x squared over the square root of y. Well, I'm going to do this in multiple steps, but again, the idea is to see if you can do it in one step eventually. Now, in here, I'm going to do it as, well, first I have a quotient. So I'm going to say this is log base 3 of the top minus log base 3 of the bottom. And I'm going to rewrite that square root of y as y to the 1/2. Now, in here, this part right here, I need to use the product rule first before I can bring this 2 to the front. All right, I need to make sure that I don't have a multiplication here. All right, I cannot just write this. This would be wrong. All right, this is wrong. This is wrong because this square is only supposed to be applying to the x, and the power rule only allows us to bring that square to the front if it's only x inside there. In other words, if it's only one value in there, not 2. So I must first rewrite it as log base 3 of 4 plus log base 3 of x squared minus log base 3 of y to the 1/2. All right. And from there, I'm going to say, well, 4 is 2 squared, right? So I'm thinking of this as 2 squared. So I can rewrite this now as 2 log base 3 of 2 plus 2 log base 3 of x minus 1/2 log base 3 of y. And that would be as expanded as possible. All right. Let's do another one. Let's say that I have log base 7 of x squared minus 1 over, let's do x squared minus 9 over, let's do x squared plus 7x plus 6. All right. So the first thing I'm going to do here is I'm going to use the quotient rule. And this is going to be just simply log base 7 of x squared minus 9 minus log base 7 of x squared plus 7x plus 6. Next thing I'm going to do here is, well, I know that x squared minus 9 is factorable. And I also see here that this would also be factorable. So I need to actually factor. And what I'm going to have here is log base 7 of x plus 3 times x minus 3 minus log base 7 of x plus 6 times x plus 1. And finally here, now I'm going to use the product rule again. So I'm going to say here I have log base 7 of x plus 3 plus log base 7 of x minus 3 minus, and here I need to be careful because this minus needs to apply to everything that I'm going to write. So in here, this is going to be log base 7 of x plus 6 plus log base 7 of x plus 1. In here now, I'm going to distribute this negative so we can get our final answer of log base 7 of x plus 3 plus log base 7 of x minus 3 minus log base 7 of x plus 6 minus log base 7 of x plus 1. All right. And again, the idea here is to not necessarily have to do it in so many steps. But I want to make sure that you see that this negative needs to apply to both of these statements. These are both going to be negative. All right. If you hadn't put these parentheses or these brackets here, you would have been wrong because you would have said, you would have shown this to be that, and you might think that that's your final answer, but you have to make sure that you distribute it to this negative. All right. So make sure you use parentheses, I guess is the point. Let's do another one. Let's say that I have, what was that, G? Right, yeah, so H. Let's say that I have ln of x squared minus 6x plus 5 over, let's do, over 2x squared plus x minus 3. All right, I'm going to do this one slightly differently than what I did the previous example, all right? Because I would not normally tackle this problem this way. What I would first do here is I would factor the numerator and the denominator as much as possible first. So in here, I would say this is ln of, on the top, I've got, well, multiply the positive 5, add up to negative 6. It's x minus 1 times x plus 5 over the denominator here, 2x squared plus x minus 3. That's going to be 2x plus 3 times x minus 1. And the way you would do that would be the AC method, right? 2 times negative 3 is negative 6, and then continue to factor out. That's what you would end up with. But what I want you to notice here is that this x minus 1s cancel each other out there, and we end up with just simply ln of x plus 5 over 2x plus 3. At that point, I would say this becomes ln of x plus 5 minus ln of 2x plus 3, and that would be our final answer. All right. Now let's do one more, and this is going to be, let's say, log of let's do 3x squared plus 5x minus 2 over x squared plus x minus 6. And again, the very first thing I'm going to do here is factor out as much as possible. So I'm going to say, well, in here, I could rewrite this as log of, the bottom one's easy to factor, right? Two numbers are multiplied to negative 6 and add up to positive 2. Well, that would be x plus 3 times x minus 2. The top one, let's just remember what the AC method was. So we have 3x squared plus 5x minus 2. 3 times 2, right, we're going to do the AC method. So 3 times 2, or 3 times negative 2, is negative 6. Two numbers are multiplied to negative 6, but add up to positive 5. That would be 6 times negative 1. And it doesn't matter which order we do them. So I'm just going to write them as 3x squared plus 6x minus x minus 2. From the first two, take out a 3x. I'm left with x plus 2. From the second two, take out a negative 1. I'm left with x plus 2. So I have simply 3x minus 1 times x plus 2. All right, so that's what we get here. 3x minus 1 times x plus 2. At that point, we're going to say, well, applying the rules of logs. Now, in here, I'm going to do this a little bit different than before. All right. The way that I'm going to look at this is anything that's on top, it's a sum. Anything that's on bottom is a subtraction. All right. That's from just the properties of the product rule and the quotient rule. So if it's on top, I'm going to add. If it's on bottom, I'm going to subtract. So what I get here as my final answer is going to be log of 3x minus 1 plus log of x plus 2 minus log of x plus 3 and minus log of x minus 2. All right. And that would be our final answer there. Notice I did it all in one step. All right. Well, essentially two steps, but the first step was just factoring. The second step here, this is what I did all in one step. And again, if it's on top, it's a sum. If it's on bottom, it's being subtracted. All right. All right. Now, this was expanding logarithmic expressions. What about going the other way? So let's talk about condensing. So condense the logarithmic expression. And in here, what was I at? I, so j. So in here, what I'm going to do is I'm going to give you an expanded log expression, and we're going to go backwards from what we did here. All right, similar ideas though. So let's say that I had 1/2 log of x plus 3 log of x plus 1. All right, we're going to start simple. So in here, the very first thing I see is I've got some coefficients here, and that means that I can use the power rule. So I'll remind you of the power rule. It was log base a of, I wrote it as m to the r is equal to r log base a of m. So going backwards here, I can say here that this becomes simply log of x to the 1/2 plus log of x plus 1 cubed. All right, notice I'm putting the cube there, so the cube applies to the x plus 1. And finally, from the product rule, I'm going to go from the sum going back the other way. So what I'm talking about is if I had log base a of m times n, we said that this was log base a of m plus log base a of n. So we're going to go this way. All right, so we're going to say that this becomes just simply log of x to the 1/2 times x plus 1 cubed. All right, and if you really wanted to, you can rewrite this as log of radical x times x plus 1 cubed, but that's not necessary. You could have left it as this as your final answer. All right, let's do another one. So that was j. Okay, let's say that I have 2 times ln of x plus 2 minus 3 times ln of x. All right, so the very first thing I'm going to do here is I'm going to apply the power rule again, and I'm going to say, well, this becomes ln of x plus 2 squared minus ln of x cubed minus ln of x cubed. And at that point, going backwards on the quotient rule, and I'll remind you of the quotient rule, that was log base a of m over n is log base a of m minus log base a of n. Barely fitted there. Could have started writing earlier. That's okay. Well, this is going to give me now ln of x plus 2 squared over x cubed. And that would be my final answer there. All right. Let's kick it up a notch. L. So let's say I had 2 times log base 2 of x plus 3 minus 2 log base 2. Actually, I don't want to use a 2 again. Let's do 1/2 log base 2 of x minus 2. And I changed my mind. I don't want a 1/2. I want a 1/3. There we go. Way better. Now, in here, the very first thing I'm going to do is I'm going to distribute this 2. All right. We'll do it in a different way afterwards, but first I'm going to deal with this 2. So if I distribute this 2, I end up with 2 log base 2 of x plus 3 minus 2/3 log base 2 of x minus 2. At that point, we can bring the exponents, right, using the power rule, bring these up as exponents. So I have log base 2 of x plus 3 squared minus log base 2 of x minus 2 to the 2/3. And finally here, using the quotient rule, I can rewrite this as log base 2 of x plus 3 squared over x minus 2 to the 2/3. All right, and if you really wanted to, you could write this as the cube root of x minus 2 squared. I'm going to leave it as that. But I did say that there was another way of doing this problem. So let's do the same exact problem, but I'm going to call it L asterisk. So we had 2 times log base 2 of x plus 3 minus 1/3 log base 2 of x minus 2. Now, this version, it's going to give us the same exact answer, but we're going to do this slightly different. We're going to work inside these brackets first and not worry about that too. So I'm going to get here, well, I'm going to put this exponent up here, right? This coefficient is going to become an exponent. So I have log base 2 of x plus 3 minus log base 2 of x minus 2 to the 1/3. Then I'm going to apply the quotient rule here, and I end up with 2 times log base 2 of x plus 3 over x minus 2 to the 1/3, giving me, well, now essentially these big parentheses out here weren't doing anything, right? Essentially I just have 2 times that. So bring this 2 to the exponent over here, and I end up with log base 2 of x plus 3 over, let's do it this way. Let me write it as x plus 3 over x minus 2 to the 1/3 squared, right? This 2 becomes an exponent over here. And I mean, that's equivalent to the answer that we had before, right? Because the last thing I could do here is distribute this exponent to each part of the fraction there, and I end up with log base 2 of x plus 3 squared over x minus 2 to the 2/3. All right, and that would be my final answer. Let's do one more. M. Let's say that I have 3 times log, let's do ln actually. So 3 ln of x plus 3 minus 3 ln of, well, actually plus 3 ln of x minus 3 minus 1/3 ln of x plus 2 minus 1/3 ln of x minus 2. All right. So here we go. I'm going to condense this as much as possible. So the first thing I see is power rules all over the place. So ln of x plus 3 cubed plus ln of x minus 3 cubed minus ln of x plus 2 to the 1/3 minus ln of x minus 2 to the 1/3. Then what? Then I'm going to say, well, anything that's an addition is going to become the numerator. Anything that's a subtraction, it goes on the denominator. So I'm going to have ln of x plus 3 cubed times x minus 3 cubed over x plus 2 to the 1/3 times x minus 2 to the 1/3. All right, because everything that was adding or positive is in the numerator. Anything that's being subtracted or negative in the denominator. Next thing I can do here is, well, I see both numerators have the same exponent, both denominators have the same exponent, so I can write this as ln of x plus 3 times x minus 3, and this piece to the 3rd over x plus 2 times x minus 2, and all of that to the 1/2. Not 1/2, 1/3. There we go. And finally here, well, I see here I have the product of conjugates both on top and the bottom. So I'm going to say this is really just ln of x squared minus 9. Let's rewrite that. X squared minus 9 to the 3rd over x squared minus 4 to the 1/3. And that would be our final answer. We cannot go any further than that. All right. So, and there, that was a lot of using the properties that we spoke about to expand and condense. Now, the last thing I want to mention in this section is called the change of base formula. The change of base formula is very helpful for multiple reasons. But first, let's talk about what it is, and then I'll say what it's helpful for. So let A be greater than 0. Let A not be equal to 1. Let B also be greater than 0, with B not equal to 1. And let X be greater than 0. Then we get the following formula. Log base A of X is equal to log base B of X over log base B of A. All right. So essentially, what this is telling us is if we're starting in base A and we want to go to a different base in a logarithmic expression, well, you could just go to whatever base you want. Just put this inside on the top, and this will be here inside the bottom. So how is that helpful? Well, it's helpful because we can apply this to base 10. If we're going from log base x, log base A of X to base 10, remember base 10 is just a common log, so I end up with just log of X over log of A. We could also do this to base E, in other words, ln, right? So if I started with log base A of X, that would be equal to just ln of X over ln of A. All right. Now, this is helpful for when you have multiple different bases in an expression and you want to just put it down to one, to just one kind of base. So that's one possible way to do it. So for example, if I had, what letter am I at? M, so N. So if I had something like log base 2 of X minus log base 3 of 7, well, because they're different bases, I can't just combine them in any way here. But what I can do is put them all in the same base using something like this. And I highly recommend that you get used to doing things in ln. All right, so I'm going to change things to ln here. So what this is going to tell me now is this is going to be just simply ln of X over ln of 2 minus ln of 7 over ln of 3. And from here, we can try to come up with a more condensed expression. We can say something like, well, if we come up with a common denominator because we have fractions here, that's ln of 2 times ln of 3. And we cannot combine that, it just stays that like that as times. And on top we have ln of 3 times ln of X minus ln of 2 times ln of 7. All right, and that would be as far as we can condense this, so I'm just going to leave it as that. But the point is that you can still come up with an expression where everything is just in terms of one possible log. Another use for the change of base formula is calculators, all right? And what do I mean by that? Well, let's say that we had this, we had to evaluate this. Let's say that we had something like log base 4 of 25, all right? Now, most calculators, most scientific calculators, only have two log buttons, ln and the common log. They don't have a log base 4. So how do we go around that? Well, what we could say here is, well, we can change this to whatever log we want. And again, I'm going to be changing things to ln just to start getting used to using base ln or base e. So in here, using the change of base formula, I'm going to have ln of 25 over ln of 4. And that I can plug into the calculator. In fact, if you plug this into the calculator, you get approximately 2.3219. All right. So essentially, this is telling us that 4 raised to that power, 2.3219, approximately, will give you 25. All right. And again, the idea here is that this right here It's not on most scientific calculators, all right? So you don't have this base 4 in most calculators. Let's do another one like this. What if I said something like log of 7, log base 7 of 23, right? And a way to think about this is saying, well, 7 to what power gives you 23? Well, that is a very annoying kind of thing to want to calculate on top of your head. So what we're going to say here is we're going to say, well, using the change of base formula, it's ln of 23 over ln of 7. You could have also done it with just the common log, but again, I highly recommend that you start getting used to ln. And if I plug this into the calculator, ln of 23 over ln of 7, that just gives me approximately, should be doing approximately, 1.6113 with a whole bunch of stuff. This has a whole bunch of stuff afterwards too. All right. But yeah, so that's another use of the change of base formula. All right. All right. That is the end of 3.3.
Wasn't that fun? If you think I made a mistake somewhere, you're probably right. Tell me all about it in the comments. If you feel you learned something from me in this video, hit the like button, hit the subscribe button, but more importantly, share it. Share this video with your classmates. And remember, you don't have to like math in order to be good at it. But you do have to be good at it. I am Jose Orozco. Goodbye.